Hi, I'm Donald McIntyre, Operations Manager at Emerald. This is the Emerald Blockchain course, Class 11, What is Proof of Stake? As a comparison to Proof of Work that we have explained in previous classes, Proof of Work uses energy to create a cryptographic hash per block. Proof of Stake uses deposits of money instead of using energy. Proof of work is a simple kind of set of rules and software. Proof of stake is more complex. For example, an Ethereum 2.0 developer said that one could code in software a proof of work consensus mechanism with 100 lines of code, and that the Ethereum 2.0 clients had 100,000 lines of code. This is because they need to add more rules to be able to make the system more secure. Uh, for these reasons that I explained above, proof of work is more secure in general than proof of stake, but less scalable. And proof of stake is a little bit less secure than proof of work, but it's much more scalable. And this, like I'm going to explain in a future class, is going to be very complementary within the blockchain industry, the two systems. This is a way of illustrating what I said about the comparisons between proof of work and proof of stake. Both proof of work and proof of stake blockchains can have the same features. No, they can have decentralized applications. They can be used for IoT. They can use for side chains or channels to increase scalability, which are layer 2 systems. And the structure of the logic of the smart contracts layer, they may have an EVM, a programming language, smart contracts, etc. And at the base, like Bitcoin or Ethereum, Ethereum Classic, they always have a ledger with accounts and balances and the token, the native token of the blockchain. This section is what is called the subjective section of a blockchain. And proof of work blockchains, they use proof of work to achieve consensus and to create a lot of security guarantees that were explained in previous classes. Proof of stake blockchains, what they do is remove this, the proof of work, so they lose those guarantees because they want to seek more innovation and scalability, and they create all a more complex set of rules or larger set of rules in the subjective section to make them more secure. In detail, or in more detail, the way proof of stake works is that it has validators, and these validators, instead of miners, and instead of using electricity, they make deposits inside the blockchain in a special account. This deposit is stuck for a long time, so to guarantee their good behavior in the blockchain. These validators do the block production. They receive the transactions like miners in proof of work, and they group them in batches. They're not really blocks because they're not sealed with energy. They're just batches of transactions. And they verify them and they send them to the rest of the network, and the rest of the network achieves consensus by receiving these blocks by these validators. When these validators are chosen to create a block, they are paid a reward, just like miners in proof of work. The structure and the timing of proof of stake blockchains is that they're divided into slots at fixed times, for example, every 10 seconds, every 12 seconds. And in each slot, a block of transactions have to be accommodated. Then the slots with blocks, sometimes they can be empty because sometimes there's latency or problems. But every 12 seconds, for example, in Ethereum 2.0, a slot is going to be created, whether there was a block for it or not. And these slots are grouped in larger segments, which are called epochs of 32 slots. This is all to organize the rules and the security mechanism. The validators, although there may be many validators, they are randomly selected to make the blocks. No? So if there's 1,000 validators or 2,000 validators, only one can create the block per slot. So the software has a random mechanism that chooses, weighted by the capital they deposited, who is going to earn the reward, create the block and earn the reward in each slot. And it's weighted by capital because if you put, say, $1 billion and the others put only $1 million in capital to be validators, then the one that has $1 billion is going to get more rewards, is going to be randomly selected more frequently just because it's weighted by the amount of capital. So if you have many stakers with some that are very big and the others that are smaller, they're going to get the rewards in proportion to that stake or capital that they deposited. There's a committee of validators per slot. So when a validator is chosen for a slot, say slot number 100, to create that block specifically, it's going to be paid. But when the validator creates the block, sends it to a set of the other validators for them to verify that the block is correct. So there is a system of checks and balances. This committee is the one that approves the blocks. That's why they're called validators. And of this committee, 2/3 majority has to be in favor of the block or vote for the block for that block to be included in the blockchain and sent to the rest of the nodes. Therefore, the fault tolerance in proof of stake blockchains is 1/3. This is in contrast to proof of work, which is 1/2. Now, 51% of the hashing power is necessary to attack the blockchain, and in proof of stake, you need 1/3 of the validators to be dishonest or be dysfunctional or to be have failure in their software or something for the network to be disrupted. Slashing is the key security point in proof of stake because all this capital that is deposited to create blocks and to receive the rewards may be slashed. Sometimes it's 1%, sometimes it's 1/3, depending on what is the failure or the bad action that the validator made. But you could get slashed, say, 1/3 of your capital if you send a block that is incorrect or a parallel block, or you try to do something that is not according to the rules. In the end, proof of stake blockchains then, social consensus is the security of last resort. This is the last security resort, because in proof of work blockchains, even if the whole social layer of the blockchain decides to collude and attack the blockchain, it's extremely difficult to create a block anyway. They would need a huge physical barrier, that is the security point. And if they want to disrupt the blockchain in the past, or transactions of the past, or balances, or smart contracts, they would need to spend enormous amounts of capital and energy all over again and take a long time to be able to do those kinds of reversals. In the case of proof of stake, the social layer and the ecosystem are the ones that are the security of last resort, and they have the security that because it's distributed and replicated in every single computer in the network, then it's very difficult to coordinate to attack it. So that's a different kind of security model. Thank you very much for watching this Emerald blockchain course. And this is the class 11, what is proof of stake? And please remember to download Emerald at emerald.cash/download. Thank you very much.